once again, you are welcome to this class and teach 232, elementary differential equation. Why do we call it elementary? You also will know at the end of the day, and it's the kind of introduction to real applications and the way we solve them using differential equation. So today we'll proceed, and from then we move to different aspects of this course. So let me quickly share my screen, then from then we'll pick it up. I have this. I believe we all have the course material, so I don't need to go over the course material again and again. Last week, we are trying to solve a problem. Here we are. We solved it. Look at this problem, and we reminded ourselves that, okay, this is what we call a general equation. This is what we call when you ask a general equation, and you have to calculate to check what is P of x, and check P of x. Then after P of x, you will be given P of x and Q of x. So after those ones, the next thing is to solve. And while you are trying to solve, what are the things we need to know? We need to do a kind of to divide through, and at the end of the day, when you divide through, what are the things that come up? We will see them clearly today. So in this way now, we are able to learn how to use integrating factor. And the formula for integrating factor is exponential, is this particular one. This is what we call integrating factor. And this integrating factor will be the tools that we use to get our general equation, which is y. So we continue to rely on this. And one of the questions in your exam that I find interesting, facilitating, is for today. Let's look at this. Today is 17/9/2022. So let's look at the question. It's a question one. As a matter of fact, it said find the general. Let's write. Don't just watch the video. Make sure you write so that when you are your own, you'll be able, general solution. General solution. Find general solution. General solution of. Please kindly mute yourself once you are not talking before I kick you out by myself. Just make sure you mute yourself for the advantage of others. Thank you. Okay. The equation says y prime plus 2y equals to x cubed exponential minus 2x. But this particular question, we have a different way of solving them. I like people to obey simple instruction, but if they fail to do that, Barry Job, what's the problem, please? You raise up your hands?
No, it has been there since.
Okay, I've lowered it. Please mute yourself. Thank you. Okay, let's move on. So when you have questions of this nature, there's something that's supposed to come to your mind. What are the things you need to know? Mayate or Samuel, please mute yourself. So in this case now, we have equation of this nature. In this nature, we have equation of this, and but there are another question, very funny question anyway, for that matter. They all together, but let's call this one number 1, and let's look at number 2. Question 2. Say, let A be a constant. Let A be a constant. Question A now says, find the general solution of y prime minus ay equals to 0. Question B says, solve the initial value problem. These are the questions. Be expecting something like this in your exam. Yes, it might be, I'm not sure whether it's multiple choice, but at this level, if you are gambling in the exam, that means you don't know what you are doing. So you need to learn how to solve some of the problem. If an examiner gives you 3 hours for a question, you know why he gives you 3 hours. So we need to solve this problem. So I will, first of all, solve question 2 so that you have better understanding of question 1. But there is a way of solving them. I can begin to represent them by a particular things so that it will not give me unnecessarily heart attack. From, let's solve it, solution now. We are solving question 2 first. We are solving question 2 first. I think I need to show you this question in your exam so that you and I will be on the same page. Let me quickly do that. Okay, look at this. This is your 2017 question. Look at the question 1. Can you see it?
Yes.
Hello? Yes.
Yes, you can see it.
Look at question 2 too. And look at question 3. 1, 2, 3. Look at them. So by the time you get to exam hall, don't say, hey, that man is wicked. Nobody is wicked. They are teaching you now. Let's learn. Please, I will kick you out again if I notice that you mute yourself, please. Aruna, last opportunity, mute yourself. Samuel, mute yourself.
Okay.
Excuse me, sir.
Is it on mute?
You are mute yourself.
Okay, I've done that, but I don't know why it kept coming back.
I'll kick you out. I'll continue to kick you out if I notice it's.
I actually did, but I don't know why
Excuse
it's
me,
coming
sir.
back on this end.
Yes.
Yes, sir. Yeah, excuse me, sir.
Go ahead.
Sorry, sir. I'm not seeing, sir.
Probably your screen. Others can see, or your network. Better off your video first. You don't need video. If I need you to on, it will help
Excuse
you.
me, sir.
Yes.
It's also blurry on my end.
It is network. Others can see. Can you see?
Yes, sir.
Very,
So
very
you
well.
can
You
see
can
my
see.
handwriting. Don't worry, just focus my handwriting. That's the major thing. Can you see this one?
Yes,
Yes,
sir.
yes.
This is what I want you to see. Don't worry. Now, look at this question now. Question 1, question 2, question 3. They are all together. So you can see 3 questions in two. So it depends the way you answer some of those problems. Are you getting the point? Please. Okay. Samuel, remember this video is not for you alone. So
You said I should.
okay. So we have this. One of the things you need to learn how to solve is you need differential equation in this case. Then you need to learn how to solve integrating factors. After that, once you can substitute in integrating factors and you impose those conditions, then you are good to go. Okay, let's solve this one. It says y prime minus, we are solving question 2 now. From question 2, says, from our calculus, we know if C is any constant, then our y is equals to, we have y prime minus ay equals to 0. Based on the general formula that we all know, in this case, we need to do a kind of separable variable. That is, let all the y be with y. Let all this x be the z. This one says, it simply means the x, the y, the x minus ay equals to 0. Now, in the general formula that I gave us last week, it says that from the general loop, it says that y prime plus, if you don't watch the video, you might not understand what we are doing. So I will advise you to go and watch the video and see what some of the questions we're able to solve. So, meaning I need something similar like this, but in this case, it's quite different. So I need to, first of all, separate, or this, in this case, you need what we call separable variable. How do I separate them? So my a in this case is a constant, but let's take it one step or the other. I can rewrite this particular problem by saying the y, the x is equals to ay. So for me to make y to be with the y and the x to be the other side, all I need to do is just to multiply both sides by the x. If I'm to multiply both sides by the x, what will I have? I'll have the x here multiplied by the y over the x equals to ay dx. So that means this one cancels this. So I will have the y equals to ay dx. So in this case now, I need y to be, divide both sides by y. I will have y divided by y because I'm trying to separate them. This one will go with this. So at the long run, I have this one now, dy over y equals a dx. So now, at this point, you have to integrate the both sides. Integrate the both sides. So if I'm to integrate the both sides, I have this one, 1 over y dy. You and I know that equals to, a is a constant. I can decide to take my a out by saying a integral of the x. Based on the knowledge of our calculus that we have, this particular one, when you are integrating this one, is what? Ln y. And when I have ln y, I call it modulus of ln y, and equals to, when you integrate this one, the x will become x, the x plus k. S plus k in the sense that this k is a constant, or k can be any value. Some people can use c, some people can use anything, but in this case, k is a constant. So, and I need ordinary y. How do I get ordinary y in this context? So we can take exponential of both sides. Take exponential of both sides. Take exponential of both sides, meaning exponential of ln modulus of y equals exponential of as plus k. So you know, this is natural log, so it will cancel this. So you have, at the end of the day, when you raise it up, what do you have? You have modulus of y. Here you have modulus of y, which is paramount to what we have, which is positive. We are taking the positive aspect of it. And this particular gentleman will be a exponential s dot exponential k. Remember, when you have s raised to power a plus b, is the same thing as s raised to power a dot s raised to power b. So that is what we use here. So since our k is arbitrary constant, we only call it anything. We only call it a constant. So it has nothing to do, anything multiplied by constant is still constant in this case. We just make it a constant. And don't forget that we cannot equate, since exponential of a raised to power s can never be 0. Remember, it can never be 0. Anything raised to power 0, exponential of 0 is 1. So definitely it's not 0. Then we will either, like this y now, you know absolute value of y is either positive or negative. Then we go for the positive. We always go for the positive aspect. So if I go for positive aspect of this one, what am I going to have here? So I'm going to have what we call y equals to, I can call this particular gentleman C. I can say C multiplied by exponential of AS, because I know it's a constant. So, and the constant has nothing to do, constant is C. So the entire thing there is constant. That's why I represent it by C. So our general y, our y will be in this case to be this. But note, where my C, I can now say where C is equals to, C can be in two forms. It can be exponential k if y is greater than 0, then negative exponential k if my y is less than 0. Remember, we are dealing with modulus up there. We are dealing with absolute value. So if my y is negative, let's say I have here now, let's say I said minus y exponential. Remember, this is positive. Minus y equals to, if I say minus y equals to c exponential ac. If I want to get y out of this place, what would I do? I'll just multiply by negative. I'll just say y is equals to minus what? Our c. We just say minus c exponential ac. But in this case, we just considered the positive that was we have there. So we can, that's why we now need to represent this condition in this format. So let's continue. Any question? So the B aspect of it says, if you go to the question again, the B says what? It says solve the initial value problem. Solve initial value problem where of this particular thing we just solved, of this one. Let me pick another pen. Solve initial value problem of this. If the condition, if you impose this condition, that's the meaning. If I impose this condition, that's why you call it initial value problem. So if I impose this condition, what will happen to me? So let me pick my pen again and go back. Then we have, if I impose this condition, it simply means, the person says, imposing the condition, y of x naught equals to y naught, right? That's the condition we want to. It will yield to, let's go to our, this is the general one that we are working with. This is what we are working with now. This is our solution for this problem. So if I want to impose it, just come here. It's meaning y naught, it will now be y naught, because we already know that y is equal to y naught is equals to c exponential as naught. There's nothing difficult there. So what will that be our c now? So my c will now equals to y naught exponential negative as naught. So don't forget that if I'm trying to substitute them, what will I gain? So let's go ahead and substitute. Now that we know that our c is equals to this, how do I go about it? Y, we now said our original y will be y naught exponential minus as naught dot, because we are substituted into the y again, into this particular y. So, and I know c is defined as this. So dot EAS. We are substituting into that equation again. Let me call this one equation 1, so that, let's say equation, this is equation 1. So putting your detail in equation 1, what do you have? Or you are thinking, what happened? Why is this one? Is this y naught we have equals to this? Remember, we already put negative on top of this now. It already changed the whole scenario. So that is why you can see C equals to Y naught exponential of this. Then when you multiply the two together, what do you have? You have it to be Y naught exponential. Something is common to them, which is A. Then take all the X minus S naught. So that is what they asked to solve. So let's take note of that problem, and that's the way to solve them. So let's move on. Any question on this?
No, sir.
Okay, let's proceed. So let's look at now question 1. Question 1 says, here is the question 1. It said, find the general solution of this type. Find the general solution of this type. The general solution of this type. Oh, sorry. Of this. So for us to find the general solution of this type, let me write here. So question 1, y prime plus 2y equals to s cubed exponential minus 2x. Remember that we've solved a problem initially that says, so if I said here, let's a equals to minus 2. Do you agree with me? Let a equals to minus 2. Yes. What's the problem? Somebody is sending a chart. Let a equals to minus 2, which implies that my y is equals to c exponential as. Remember that we started from here. Sorry for that. So let a equals to minus. Remember, we started from up. I'm trying to relate what is happening here. So in this case now, what we need to do is very simple. There are many ways of solving this kind of problem, but now let's continue with this one so that. So which means I have here, see, I want to do something. If you look at this question, we have two s here, s raised to power 3 and s raised to power and exponential of minus 2s. You can't treat it the way you treat others. You need to, first of all, apply product rule to solve this problem before you can move on. If not, you might not get it rightly. So y prime plus 2y equals to 0. If I said is equals to 0 like this, then I will now say let y equals to u exponential minus 2x. So I need to first of all resolve this y, or you can call it any alphabet, depends on you. Now, for me to solve this one, using product rule, remember in product rule, you differentiate one, you hold one constant, you differentiate another one, you hold another one constant. Let me differentiate u first. I said u prime, I'm saying u1, y prime now, I'm differentiating it. U prime, I'm adding exponential constants minus 2x. Now, if I'm differentiating exponential minus 2x and odd u constant, what do I get? I will have minus 2 u exponential minus u x. Now that I have this, and I know I can go ahead and substitute into my equation, what will I get? If I want to go ahead and substitute, remember that I still have the same equation. So how do I substitute this one? Go back to the equation 1. But for us to go back to equation 1, something has to be done urgently. So let's go to equation 1. Equation 1 will be, substitute everything into it. We have y prime, or let me call this one equation 2 plus 2y equals to, yes, Bisola?
Okay. Sir, please, I don't understand how when you differentiated and you got that u became u prime. I don't understand how the u became u prime, but I understood how how you differentiated the exponential, but that's you how it became u prime is what I don't understand.
You guys need to refresh your calculus very well. Remember, this is not calculus class, but for once, I will explain. Let me just claim this.
Thank you, sir.
Now, what is the formula for product rule? Ibrahim, yes? Ibrahim.
Okay, hello, sir. Yeah, I'm trying to even understand from the beginning where you wrote let a equals to -2.
Yes.
And so I don't understand where you got that from.
Okay, good. That was what I was expecting question from. Remember that we already have a general solution here, with the one I circled in yellow.
Okay.
It is more or less general solution for this problem. The difference is one is equals to x raised to power 3, and the other one is positive, the other one is negative. Remember that the first one is talking about positive 2y, while the second equation is talking about negative a. Are you getting it? I'm just using one stone to kill two birds at the same time. So now, if you look at this, for us to solve this problem, there are certain things we need to follow. Because we have s raised to power 3. Remember, I only taught you the last time the one of integrating factors. But in a situation whereby you don't apply integrating factor to some question, remember this is supposed to be our qx, right? Ibrahim?
Yes, sir.
And this is supposed to be p,
but
p what?
The only thing is that the s square and e raised to power 2s make it look different from the regular qs.
That is why we are using this approach. Are you getting it now?
Yes,
that
sir.
is the reason why we're using this approach, because it's different and we can't treat them the same way. So that is why we are trying to use this approach and follow this approach to the letter. So this particular one has products, while this one has the same. That's why you have to sit down and think about it one after the other. Maybe where probably the way I think you guys will grab you didn't grab. Let me start from here. Let me just clean this. Don't worry, it's still the same thing, but I want to just break it down more. Okay, you have this y prime. Okay, let me write it. Let's say let's u equals to x raised to power 3. Let u equals to x raised to power 3. Then I have y prime plus 2y is equals to u exponential minus 2. Do you get it now?
Yes, sir.
Okay. Now that you have this, but I can go ahead and say, okay, I know I can now say, remember I have exponential minus 2. I may not even represent it. I can just leave it this way. The way I'm trying to represent them, I can just leave it this way. So if I have this, what is the formula for product rule? Because
V du dx plus u dv dx.
u
dv dx plus v du dx.
dv dx plus v du ds. So anything can be your u, anything can be your v. It depends on the problem you are solving. Let's say we said, let u equals to u and v equals to exponential minus 2x. If I want to say du dx, how do I solve it? Any problem?
Du dx will be du dx.
That's why I call it u prime. Are you getting it now?
Yes, sir.
Yes. Busola, are we there now?
Yes, sir. Yes, sir.
Now, dv ds is what? Minus 2. Do you agree?
Yes, sir.
Exponential minus 2x. Then substitute it here in this formula.
Okay.
So you have it to be, what is my u?
U prime.
U
U is u
equals to, dv ds is what?
minus 2
Minus
e raised
2.
up.
Let's say minus 2u exponential minus 2x plus what? Plus v, which is u prime exponential minus 2x, right? Then if you rewrite it, it's going to be u prime exponential minus 2x minus 2 minus 2u. Am I communicating now? Exponential
Yes, sir.
minus 2x. Shikena. So this is what is equivalent to the other side of the, when you solve this. So we can now proceed. If I ask you to now substitute it, how do I substitute it into the problem that we are having? Who can tell us what to do at this point? And don't forget, that is first phase. We call this one, remember, everything here is the entire year. We call this let me clean this formula. You don't need this, it's for elementary students. So here we call it y equals to u exponential minus 2x. Then the entire here, we call this one y prime equals to this. That is, when you differentiate everything here, it gives us this. So if I go back to this place, I can substitute the y. You can begin to substitute. You can say my y prime, my plus 2y, right? Plus 2y is equals to, now be substituting it one after the other. I know y prime to be u prime exponential minus 2x minus 2u exponential minus 2x. Then, what is my y? In this case, remember you are substituting it here. I just substituted y prime here. Then I need to substitute y2. Will now be plus 2. What is the entire y? U exponential minus 2. Any question? First thing is, I find my y. I know my y. I know my u. I know my y. I know my y prime. Substitute y and y prime into the real equation that you have from the beginning. That is what I did. Any question, please? Any question? Hello? Silence means no question. Yes?
No, sir.
What do you say?
No, sir. No question, sir.
No question. Okay. So I can now go ahead and resolve this one. What do I have here? Does anything cancel each other?
Yes.
This one go with this, right?
Exponential minus 12. Okay, sorry.
It goes, yes. So
exponential minus 12.
Yes.
It cancels each
and
other.
I have it to be u prime exponential minus 2x. Thank you.
Minus, okay.
Am I right? Don't forget, everything here is the one that equals to this. Am I right? Now, let's go back to our original equation. Yes? Any question?
You are right, sir. That's our final answer.
So, don't forget that you have everything here. You have y prime plus 2y is equals to this. But to your surprise, I can now go back to the equation here. This is what I did. I said, remember, I just put this one. I said everything here is equal to. Now, we still have this, but the way we solve it is, let me just show you. So you now have u prime exponential minus 2x is the same, is equals to s3, s raised to power 3 exponential minus 2x.
Because we represented that x raised to power 3 with you.
Exactly. You have to go back to it. But remember, the solution says u prime. How do I get the prime out of it? Meaning that I have u equals to s raised to power 3. Then who can tell us u prime is equals to?
dy, okay.
U prime is the u, the s, which is equals to what?
The u dx, sorry.
S raised to power 4 divided by 4. Do you agree with me? No?
Yes, sir. We differentiation, we are integrating, sir.
You have to integrate now in this case.
Okay.
Remember,
Okay, we are
if you have the u, the x is equals to s raised to power 3, then cross multiply because we need the u. We need our u back. Anytime you have differentiation, differentiation will bring different. When you integrate differentiation, it will give you ordinary u. So we now have the u equals to s raised to power 3 dx. Now integrate the both sides. We need our u. So here, when you integrate the u, you have u equals to, when you integrate this one, you have s raised to power 4 divided by 4 plus c.
Arbitrary constant.
Don't forget, you are here. Let's call this one equation triangle. So
God of nothing.
Now, remember, we are working towards a particular goal from here. So for us to now write, now that we know our u, I can go back and substitute my u into my value. So where do you think we substitute the u? Let's from here. Where do you think we substitute the u here? So we have it, our y will be where we have y. Where do we have y? Go to your y. You look at your y is
Y
here.
equals to u exponential minus.
Let me call this one equation 1 and call this one equation 2. Then we can now go our y, record that your y, can somebody call the y for me? Y is equals to what?
U exponential minus
2x.
It now becomes, that's the general solution, y equals to exponential minus 2x in bracket the whole u, which is this.
Okay, sir.
So in bracket s raised to power 4 divided by 4 plus c. This is what we call general solution.
Okay, that's our final answer, sir.
Yes. So it's a bit tricky, but you have to be careful when you are solving it. Let me run the step again before we move for today's work. Please mute yourself.
Okay, sir.
So what we did when you have this question is, first thing is we represent our u by this. Now, we represent u to be in this format because of the power and because we need to solve our problem, and our equation becomes this. When your equation becomes this, we need to first of all resolve this one because they are all function of x. So while we are trying to resolve them, we use product rule. Product rule says differentiate one, hold another one constant. Differentiate this, hold another one constant. Then before then we said let y equals to everything here we have. Then we differentiate y to have y prime. After that, we know the general equation says y prime plus 2y. Then I can substitute my y prime that I differentiated the other time, put it in the equation. This is what I did here. This is y prime here. Then plus 2y. This is my 2y. This is y prime. So then after that, sum cross out. The remaining one is u prime exponential of minus 2x. Then the next thing to do is I need to find my u out of my u prime. I need to integrate both sides. I know my u is equals to x raised to power 3. Then for u prime now, so at this point, the one that is equivalent at this point is equivalent to this. And I need u, and this is the same already. So I don't bother myself with that. So the one I need u for, I need to go back to it. For you to have u from u prime, you have to integrate both sides. So after integrating the both sides, I have this. And I go back to my y, which is, my y is this. Then my y becomes, substitute my u back, and I have my general solution. Any question? You will have the video later, but let's continue. So let's quickly move on to I promised to solve that one last week, and that is why we quickly solve it. Then I would advise you to go and read the theorem, existence and uniqueness theorem. Make sure you read it, and from then we can also look at the examples on that particular format in case you have any issue. All you need to know is it continuous? At what point is there in your material? Existence and uniqueness theorem is there. Look at it and look at the example. How do they normally use them? So how do we, at what point it is continuous? The particular function is continuous, you know that. And at what point it exists, you and I know. You need to first of all look for that. Then after you've looked into that, at what point is uniqueness? Uniqueness comes after you partially differentiate your function. You differentiate it with partial differential equation, then you will now be able to see the point at what point it's the function is unique. But for today's class, what I have for you is, let's continue. I have this, let's say, number 3. If you have a question, let's say the y dx equals to, I want to teach us the particular solution. We have general solution and we have a particular solution. So we will be trying the two together, and from then we'll be able to see how we are going to go. Just give me a minute. Sorry for the interruption. So we have y. We want to see, how do we find, okay, let me write the topic so that you will know particular solution. How many of us have seen a question on that? Is there in your manual? So the question says, find the y, the x is equals to x squared over y squared. Now I said A, find the general solution. B, find particular solution. So when y of 0 is equals to minus 2. So we are already moving towards the initial value problems gradually, but let's look at this. So the solution in this case is, that is where separable variable comes in. So we have the y, the x is equals to x squared, y squared. Please, who can tell us what to do in this case? How do we separate this?
We cross multiply.
Really? Okay. No.
Okay.
Yes, sir.
Don't discourage yourself. Yes.
We have y squared dy equals to x squared dx.
Okay. After that,
Then we integrate.
no. So let's look at this. How do we do this? Multiply both sides by the x. You will see what I'm saying. By the x. Multiply both sides by the x, which simply means the s in brackets the y over the x equals s squared over y squared multiplied by the x. This go with this. Are you getting it now? So, or yes, let's say this goes with this. On a normal day, okay, maybe I should say multiply both sides. Let me change this one by saying y squared dx. I will explain later. Y squared dx. Multiply both sides by y squared dx. So it's going to be y squared dx. You agree with me? This will go with this one. So at the end of the day, I will write it by saying y squared dx. Y squared dy equals x squared dx. You said we should cross multiply. It's more or less the same, but that's not. If you look at this question, not all the questions you can easily cross multiply. I'll give us another one. You will see what I'm saying. Now, but learn how to delete the denominators. How do I delete the denominators? Is you see the denominator we have the x y squared. So once you multiply both sides by the denominators, it will cancel out. Then you have something you can play with.
Okay, sir.
Yeah. So we can go ahead and integrate both sides. Please mute yourself. Who is that? Just mute yourself, except when I ask you to talk, please. So we have integrate both sides. Integrate the both sides. So we have integral of y squared dy equals to integral of x squared dx. So when you integrate this, what do you have? Anybody?
We have y raised to the
power of 3 all over 3 and x raised to the power of 3 all over 3
plus c.
Plus
mute
1.
yourself, please. Once you know there is a background noise where you are, please mute yourself.
We have y raised to the power 3 plus 1 equals to x raised to the power 3 over 3 plus 1.
Where do you see 1?
Plus x, rather.
Where do you see x?
When we integrate
x3 over 3 plus c2. So at this point, I can.
Please, a question, sir.
Yes.
Please, how do we get that C1 and C2, sir?
from the knowledge of your integration.
Okay. Okay.
When you
Okay.
have in integration, you have y equals to s raised to power n. When you integrate s raised to power n, what do you have?
Okay.
You have x raised to power n plus 1 over n plus 1. Right?
Okay.
Everything plus c. That's all.
Thank you. Thank you, sir.
So C1, C2 that I put, because I know they are all constant, I will still make them a single one. I'm just using this. So if I multiply through by I can combine all my C to be 1. I can say y raised to power 3 over 3 equals to s raised to power 3 over 3 plus c. Because if you said it's plus c, it's still the same. Because c plus c is still c. C1 plus C1 is equal to C. So, or if you still want me to maintain it, it's still the same. So at this point, I can multiply through by 3. Multiply through by 3, I have y raised to power 3. You know, when I said multiply through by 3, it simply means 3 in brackets, y raised to power 3 over 3 equals to s raised to power 3 over 3 plus c over 3. So this one will cancel this. So at the end of the day, I have what? I have y raised to power 3 equals to s raised to power 3 plus c. I know you will say c3. Yes, you are right. But constant multiplied by is still constant. So that's why I just write c. But now the problem is I need y. How do I make y out of this place? Anybody?
Cube root of both sides.
You said?
Cube root of both sides.
I will do what?
Cube root of both sides.
Thank you. You can take cube root of both sides. If you take cube root of both sides, because it's only cube root, remember from law of indices that when you have y raised to power 1 over 2 is the same thing as square root of y, right? When you have y raised to power 1 over 3 is the same thing as what? Cube root of y. So now we use this method in solving this problem because I know that cube root will multiply is 1 over 3. So it will cancel this 3 if I multiply it at the end of the day. If I said cube root of y raised to power 3 equals to cube root of s raised to power 3 plus c. So in this context now, I know that y raised to power 3 multiplied by 1 over 3. That's the meaning of cube root, right? So automatically you have ordinary y. So this one will be y equals to cube root of s cube plus c. This is our general solution. This is our general solution. Then the question now said we should calculate our particular solution. For particular solution, what you do is for particular solution, what you do is at y of 0 equals to minus 2, meaning anywhere you see 0, particular solution means calculate your c. That is what they are saying. That is the meaning of particular solution. You are to calculate your c when y is equals to minus 2 and your s is equals to what? 0. What this one means, it simply means when s equals to 0, y is equals to minus 2. That's all. So let's go there. You have minus 2 at initial condition, minus 2 equals to cube root of 0 square cube minus or plus what? Plus C. Is that all? So plus C. But in this case now, how do we resolve this problem? How do we resolve this problem? Any problem?
Suggestion, sir.
Yes.
We'll firstly solve the one inside that cube root, and then after then we'll move further.
Now, I agree with you. So if you look at this, I come back again to this particular problem. Before then, what are the things we need to do? Let me just remain this one so that, let me just put it in the general solution is this. But now, if I want to solve this problem, I have minus 2 equals to, this is 0. Is 0 raised to power 3 is still 0, right?
Yes, sir.
So we have cube root of C. Now, I need somebody to tell me, how do I get my C, ordinary C, out here? Anybody?
We're going to find the cube and we're going to like square both sides by cube.
I can't hear you, ma.
You will divide both sides by the square root
We are
of
going
3.
No,
Are
we're
you
going to
dividing?
cube. No, we're going to
You
multiply
find
by
C.
cube raised to power 3. Like
You
minus
multiply
2.
raised to power 3. God bless you. So everything will be raised to power 3 because remember that C is 1 all over 3. So you have to multiply by 3, raised to power 3, exponent of raised to power 3, everything. So you raise everything to raised to power 3, it will now be minus 2 raised to power 3 equals to the entire whole raised to power 3. So at the end of the day, this one will nullify this. So you now have minus, this one will be what? Minus 2 raised to power 3 is what?
Minus 8.
Minus 8 equals to C. So that is how we got it. Therefore, your particular solution will be y equals to cube root of s raised to power 3 minus 8. That is particular solution. This thing is not hard if you can practice. Any question?
Hello, sir.
Yes, go ahead.
Yeah, I'm a bit confused. From when you say when x is 0, y equals to minus 2. Sorry,
Yes.
I don't understand where that came from, sir.
Where we got it?
Yes, sir. Can I say something, sir?
I'm coming. This is it. It's on the question. Look at it.
Oh, okay.
You will be given that condition. It is not
All
me
right, sir.
that just implement it. It's the condition
Okay.
you are given that you apply.
All right, now I understand, sir.
Okay. Yes,
So I have
another
a
question.
Yes, sir. From where we have y raised to power 3 all over 3 plus c1, somehow, I think the c just became 1. I
Okay.
don't know how that.
What I'm saying is, in most cases, constant plus constant is constant. Constant multiplied by constant is constant. Are you getting it? So they are both constant. I just make sure I make them okay. I can
Because
also say that don't even bother if I don't put this one there. That does not mean what I'm doing is wrong.
Okay.
Are you getting it?
Okay, sir. Because I was thinking even if we are to collect the likeness and take the other
It
c
will,
to that.
but you cannot cut. Remember, because negative will now be C2 plus minus C1.
It give us C.
No, it's not like that.
But I
That
think,
is
sir, I think it is general formula, like arbitrary constant. So it's
the
always constant.
arbitrary. If you read your material, it's stated there. They call
Yes,
it
sir.
arbitrary constant. So you don't need to worry yourself on arbitrary constant.
Thank you, sir.
So all you need to do is just to get one of it, because that is what we are using to solve the problem. Please mute
Hello,
yourself.
sir.
Yes.
Please, sir,
What?
I'm confused where you got -8, sir.
Minus 2 raised to power 3 is what?
It is -2 times -2 times -2.
This Shona, it's minus, it's not plus.
It's still minus, because -2 times -2 is +4. Minus another -2 is on ground. So -2 multiplied by +4 give us -8.
Are you okay now? Okay. It is well with your class. Let's continue.
Yes, sir.
All of you guys need to go back to your original store. Okay, let's look at the value problem, initial value problem. Initial value problem. Okay, but I have this question for you. Let me give you so that you will say that man. Okay, number 5. Let me call this number 4, right? Let's say the y, the x, I want you to go and solve it, equals to 2 raised to power y. And you have a condition of 1, -1. So what is y when s is equals to 3? So you have to solve this one on your own. What is y when s is equals to 3? So when you have a question like this, how do you solve it? So let's go number 5, initial value problem. Initial value problem. You have the y, the x is equals to 6x minus 3. Y of 0 equals to 4. When I say y of 0 equals to 4, what does it mean?
Means when x is 0, y is 4. X is 0.
Equals to 0, y is equals to 4. So please take note of that.
Of x.
So here also we separate the variable. Let x goes to x. Then now at this point, look at what I was telling you the other time. You cross multiply. That means I have to put 1 under this one. So it simply means multiply both sides by the x. When you multiply both sides by the x bracket the y over the x equals 6s minus 3 dx. So this one will go with this. You have the y equals to integrate it. So when you integrate, what do you have? You have y equals to 6x squared over 2 minus 3x, everything plus c. So at the end of the day, your y is equals to 3x squared minus 3x plus c. This is your general solution. So the question is, you can imagine this for now. If you are not in class or you don't know how to solve this problem, you think it's hard. But now the question now says, when y equals to 4, s equals to 0, let's substitute and see. We want to calculate c. That is the y. Y equals to 4. We have 3 of 0 squared minus 3 of 0 plus c. So you agree with me that my c is equals to 4. Then go back to generalized solution, which will now turn to IVP, that is initial value problem solution, will be y equals to 3x squared minus 3x plus 4. That's what they asked you to solve. So let's look at number 6, right? This is 5. Let's look at number 6. Under the number 6, what are the things we need to do? Under the number 6, we have the y, the x is equals to 2xy, where you have y of 0 equals to 3. Y of 0 equals to 3. So when you multiply again, this is another form. The y, the x equals to 2xy dx. So you have the y equals to 2x. So 2xy dx. Then divide through by, yes, Charles.
All right, so I just want to ask, what is the difference between an initial value problem and the particular solution?
More or less they are the same, but the way they ask is different. They will just give you, they said initial value problem, IVP is equals to this. But remember, most times, before you get to initial value problem, you have to first of all reach general solution first before you substitute. The same thing will happen to particular solution too. Before you reach them, you have to go through the general solution. That's just the meaning. Then if you check your book, there is this book, there is this definition here. Let me show you. It's there in your notes. At what point do we have I know somebody is raising up the hands again. Ibrahim, or who is the second person?
Yeah, I'm the one. I just want to say that the general solution has a constant. Why the initial value problem solution means that the value of the constant will be substituted to the equation.
So you can see here, look at this way, look at this definition from here. They said, thus we would like to impose some condition on the solution which might determine A. We are coming from A up, where A greater than 0. One such condition is simply specify the value of Y at some point of X naught, at some point of X naught here. Then is in the interval of the existence of Y. Such a condition is called initial condition. That is the first question I saw. They have initial condition of Y naught equals to S, Y of 0 is equals to S naught. So then initial condition, and the problem of solving differential equation together with initial condition is called, because they can ask you, remember it's OBJ, they can say, at what point do we have initial condition. What do they call initial condition? Or differential equation of together with initial condition is called initial value problem. But let's look at particular. I think there is one dimension. Okay, look at the particular solution. Any solution which is obtained from general solution by giving particular value to arbitrary constant is called a particular solution. Please take note of the difference between the two. Thank you. They are there in your books. And as you can see, they might look the same, the method might look the same, but the definitions are different. Please take note of that. That's why you see what I did, I name it. So here you divide through by y, divide through by y. Here y cancel this. So you have here integral of 1 over y dy equals to integral of two x dx. So I can go ahead and solve this problem by saying I have lane y equals to 2x squared over 2 plus c. So if I take exponent of both sides, I have exponential y here equals to exponent of s squared plus c. Remember the way we break it down the other time? So I can jump here by saying y is equals to c exponential s squared. Now, we are given initial condition from here, which is when s is equals to 0, y is equals to 3. So I have 3 equals to c exponential 0 squared. Anything raised to exponential raised to power 0 is 1. So our c is equals to 3. Then go back to your general solution, which is this one. Your general solution is here. General solution, let me call it GS. Then I can substitute it there. My y in this case will be 3 exponential s squared. You see a lot of this question in your work. So please take note of that and do yourself favor by solving some of them. Any question, please?
Please, let's see the question again.
Which of them? This one?
Last one.
Okay. So they can also give you in another form. Another form of solving this problem, I'll give you now, and I'll ask you to solve one before we close for today. Another one I want to solve with you is this. If I ask you to calculate a particular, if I said, find the particular, I've seen something like this also. Solution. Remember here, they did not mention find general solution of the differential. Number what is this? Number 7. So of the differential equation given the initial condition given initial condition. Initial condition in this case, they just say, okay, look at the question. Let me just give us this. The question is f prime prime of x is equals to 2x minus 3, where your initial condition is given f prime of 1 is equals to 2, then f of 0 is equals to 3. So who can tell us what to do in this case? Anybody? Okay, let's continue. Solution will be, remember what is f prime prime means, please?
Differentiate it twice.
You have to differentiate twice.
Differentiate
right?
twice.
Good. But in this case, we know that it's integration we are dealing with. So you now have it integrate f prime prime of x dx equals to integral of 2x minus 3 dx. Are you seeing another method of solving it? When I integrate this one first time, it will reduce the power of differentiation, right? It will be f prime of x equals to, now integrate this side, I have 2x squared over 2 minus 3x, everything plus c. So this one goes with this. I have f prime of x equals to x squared minus 3x plus c. Now, look at the boundary condition given to me up. The boundary condition says what? The condition says what? Whenever when s is equals to what? I'm talking about this. I'm talking about this now.
Yeah, when it's equal to 1, the y dx equals to 2.
Yes, f prime will be equals to 2, right? So substitute it. That is f prime of x, rather, is equals to 2. So anywhere you see f prime, substitute 2 equals to, what is this one? 1 squared minus 3 of 1 plus c. So I have 2 equals to 1 minus 2 plus c. C is equals to 4, right? Now, substitute c equals to 4 in f prime. S squared minus 3x plus 4. So please mute yourself. If you are not asked questions, mute yourself. So we continue by saying, what you need to do, you perform the second operation to integrate. Integrate f of prime of x equals to integral of x squared minus 3x plus 4 dx. So what do we have here? So when you integrate this one, you have f of x now equals, let's integrate this one, s cubed over 3 minus 3x squared over 2 plus 4x plus k. Let me use this one, k now, because I use c up. Anything can represent my arbitrary constant. So, and the question says f of 0, the condition says f of 0 is equals to what?
3.
So I have f of x to be 3 equals to 0 minus 0 plus 0 plus k. So it simply means my k is equals to 3. Then I substitute k back to the original solution, which is my f of x is equals to x raised to power 3 over 3 minus 3x squared over 2 plus 4x plus 3. That is the answer for this problem. So on your own, I want you to go and solve this one. I'll call it 8 for you. Make sure you solve it. Don't deceive yourself. Nobody. Then make sure when you solve it, scan it to me. You have your scanner on your phone. Just scan the sheet of paper and send it. X raised to power 2 minus 4, making two questions I gave you now. F prime of 2 equals to 3, then f of 1 equals to minus 4. So we have to solve it. If you solve it very well, I have the answer already. So let me see what you get. Then.
So are we doing it right away?
No, because I want to explain a population problem for you. I will not allow you to do it now. Let me just quickly explain that population problem. Is there in your textbook? I saw something similar there, and I think it is better I explain it to you. Now, if you look at question 9 on your, it said, in the following problem, derive the differential equation describing the given physical situation. We have a culture. A culture initially has a population, a P0 number of bacteria. The growth of bacteria is proportional to the number of bacteria present. What is the number of P of bacteria at any time, T? So what this question is saying is they are talking about the population. And how do we solve the population problem? Initially, when you have the population like this, let's say we represent population, let's say the P, which is over the time, the T, which is equals to K, P. K means this, this K is the what is the growth. What is responsible for the growth of the population? Why your P is the population size. So are you getting the analysis now? P is the population size. Now, if I have something like this, let me just go back to it so that you have idea. Now, I know that for me to solve this problem, I have the P over the T is equals to KP. For example, if I take, if I say my population size is 1,000, my sample of bacteria is 1,000. Let's say I have 1,000 sample of bacteria. Then at what rate are they growing? Let's say 50 per hour. 50 per hour, they are multiplying. They are growing. You know, it's a bacteria. So If I increase the population size of that sample size, automatically the growth rate will also increase. Let's say I said 2,000 now is my sample size. Then you should expect K to also move up. If my P move up, K will also move up. Let's say K is 100 per hour. It will also move up. So that is why they want to know at what point are this thing happen. So now let's look at it in the general population. That's what they use when they said Nigeria is, what's the population of Nigeria now? Anybody?
Over 1 billion or so.
Over what?
Over 200 million, 220.
Over 200 million. So they use this kind of model to know with different stuff that matters, different condition. But now let's look at this, the P, the T. You two also, you are a mathematician now, you can know what it means. So what you need to do, multiply both sides by the T, right? When you multiply both sides by the T, you have the T multiplied by the P over the T equals to Kp dt. So this goes with this. So you have dp is equals to, divide both sides by P again, the way we did the other time. Let's go first of all write this one. When you divide both sides by the P, by P, so this one cancel this. So you have integral of 1 over P dp equals to integral of K dt. So I can integrate this one, I'll have ln P, right? Equals to K T plus C. So when you take exponential of both sides, you have P equals to exponential of KT plus C. So at the end of the day, what is P? Our P will now equals to C exponential KT. But if I want to know the one of P naught they mentioned here, remember they mentioned P naught here. The P naught they mentioned here is talking about, P naught they mentioned here, you look at it, initial. For some of us in chemistry, biochemistry, or you are doing biology, you know what they call culture. Culture means they try to make up some things out of it. A kind of a practical, of procedure they use to culture a cells. So that is what they are saying here. So here we can proceed by saying that, okay, now my P, I can say at P naught, at P of 0, I have what? That is at P, remember this is P, okay, let me write this one very well so that PT is C exponential KT. So as when T is equal to 0, what happened? I have C exponential of 0, right? So we have P of 0 to be equals to C. P of 0 is equals to C. So I can now go ahead by saying P of T is the same thing, that is, which implies that P naught is equals to C, constant. Then P of T, I can now put it as initial, that is, since I know P naught is equals to C, I can substitute anywhere I see C now from this model. From this model, I can substitute P naught there. That is P naught exponential KT. So that is for the population. But you can also relate it to the real life problem. Let's look at the last question here. Let me call this 9, or let me call this 10. Look at this. Write this question down. The table below shows the bacteria sorry, okay. The table below shows the bacteria population, Let me just use this word. On a certain experiments. Where T is the number of years or time, it depends, of years, let's just say of years. Beginning with the year 2000. Now, then I say A, determine the relative. You can use anything. It can be animal, it can be human being, but no, it's not necessary to be bacteria. Determine the relative growth. The relative growth rate. B, write a general equation for the population of P of T. C, estimate. You can also estimate the population in 2020, or yeah, in 2020. And D, how many years will it take for the population to double? How many will it take for the population to double? So let me quickly give us the table. Says we have the table here, year. Our time is fast spent. I have other stuff, but let's quickly do that. Year population. In year 2000, the bacteria we have is 1,500. 2001, 1,577, 2002, 1,658, 203, 1,743, 2004, 18,000, 2005, 19,000. So we have this. Now, for us to solve this problem, you don't need to go over the model again. You already have the model. This is our model we are working with now. Right? This is the general population model we are working with. So all you need to do is just to solve. Solution. We just put P of T is there in your notes too. P naught exponential KT. Then initial condition, our P naught here is what? Who can tell us?
C.
Is what? Anybody is on the table. Who can tell us? Is what?
15.
1,500, because that's the initial condition. That's the starting point. Starting point is initial condition, where is the point of rest, where you are starting from. So it's 1,500. Call it. So we have 1,500. Then I can go ahead and substitute it. So I know that at the point of initial, I call it this, P of 0, meaning P of 0 is 1,500, where T, when T is equals to 0. So I can go ahead and say 1,500 is equals to 1, is equals to what? Is equals to P of 0, because I want to check the first thing they ask us to say to determine the growth rate. So it's going to be P, let's substitute 1,500 here, P naught exponential of K of 0. So you have 1,500 equals to P naught of 0. At the end of the day, P naught of 0 is equals to P naught is equals to what? 1,500 equals to P naught. So that's what we quickly use to check, which is the same thing as P of 0. So now that we have this, but if you check the first year, what do you have? If you check the first year, what do you have? If I check the first year, I will have P of 1 now. P of 1 will be 1,577. So meaning I have 1,577 equals to P naught, which is 1,500, exponential of K of 1. So I can take this one to the other side. How do I do that? Divide through by 1,500. 1,077 divided by 1,500 equals to 1,500 exponential K of 1, which is divided by 1,500. So this one goes with this. So if you do this one very well, you have 1.0513 equals to exponential K. But what I need is K. How do I get K here? Anybody? How do I get K?
You do lean of both sides.
Thank you. Take the lean of both sides. If I take the lean of both sides, I will have lean 1.0513 equals to exponent equals to ln exponential k. So this will go with this, and I have, when you do the ln of this, you have 0.05 equals to k. So our P of t now, our P of t will be 1,500 exponential 0.05 of t. So that is the second, that's the general solution they ask us to write in second equation. After we've calculated, determine the relative growth rate. Growth rate is k. As I explained to you initially, that's the growth rate. And after that, you substitute your growth rate into your model, which we all believe, and this is B, this is A. So the next thing we need to do is what we should estimate in year 2020. According to the table, 2020 will be in 20 years, right? Hello?
Yes, sir.
Thank you. So if you have P of 20, what do you have? Somebody should multiply it and give us the final answer. That's your answer here. So the last one says D. He said, how many years will it take the population to be double? How many years? How do we estimate that? How many years will it take the population to be double? Anybody? No answer. Okay. When you get to your time, please go and solve it. Is that all? Any question? Silence me, no question.
So I want to ask him.
Please ask.
Like this population model that we just did, we arrive at the general solution.
Yes.
Can we come across situations where we'll be asked to look for the particular solutions in regards with this population model?
We already have the general population. No, most of it is just a kind of, you don't need to cram that one. It is just when it comes to general population, what it means is, general solution is, I just show you the application, the way we apply it. Nobody is not all the questions will be asking you, find the general solution, find the general solution. We are moving higher. It's just an introduction. So that, because by the time we are applying the general solution here and there, you also follow the truth.
Okay, sir.
Any other question? Do you want me? Yes.
I have a question, but it's related to our TMS, but not this class.
Which class?
As in, what I want to ask is not in relation to what we just learned now. I want to ask a different question entirely.
What is the question?
Like some of us are having some issues with our TMAs, and sometimes we have wrongly programmed the questions and options, and sometimes we have a situation whereby we are marked wrongly. And we are very sure that we got the answer correctly, but at the end of the day, we are marked wrongly. I don't know, sir. Are you the right person to complain to? I don't know who to complain to.
Is the management you complain to? Just make sure you send your. When I was talking about on that, can you still see? Can you still see my screen?
No.
sir. No, sir.
Can you see it now?
Yes, clearly, sir.
Yes, sir.
Okay. So when they asked you that the double is how long will you be double the population? Simply means you remember that our initial is 1.5. So if initial is 1.5, I can double initial by make it 3,000, right? To be equals to 1,500 exponential 0.05t. I need the t. It's the t that I'm looking for. When I divide both sides, I have 1,500 divided by this equals to exponential 0.05 t. So here I will have what we call, I will have 2 equals to exponential 0.05 t. Take the ln of both sides, ln 2 equals to ln exponential 0.05 t. So this will cancel this. I have ln 2 equals to 0.05 t. Divide both sides by 0.05. So when you divide both sides by 0.05, what do you have? You have ln 2 divided by 0.05 equals to t. So when you do it very well, we'll be looking at approximately your t will be equals to 14 years.
So the answer to that, the one of 20 years is 40,077.
Okay, thank you.
4,077.
Okay, in 20 years. Okay. So in 2020, but in this case, if in the next, when we're going to double it, it depends. If you change this one to 10, what do you have? Change this one to 10, please. If you change it to 10, what do you have? Let me change it to 2010. If you change it to 10, what do you have? So approximately you have this. So these are the things that you should worry about and try to work on it. And at the end of the day, by the time you work on that, it will help you. And so I make sure you scan your question, your solution to me for the 2 questions that I gave you. Don't just take the picture, scan. When you scan, you send it in PDF for me. You have my email address, send it to my email address. I think it will be better. So we communicate through that. Any question?
No question, sir.
Okay. So on this note, we'll call it a day. Thank you for coming. See you guys next class.
Thank you very much.
You're welcome.